All right. Thanks everybody for coming out. My name is Scott, and we're going to be talking about some legacy code in Python today. So before I get started, I want to give a shout out to my company, kind enough to send me here. I work with Yelp, which, if you don't know, is a website for finding local businesses near you, making sure you can sort of get what you're looking for. Very useful for me when I'm traveling in cities I don't know and need to find somewhere to go to dinner. I've been there for about 4 years now, working on a variety of back-end teams, and these days I work on what's called the transaction platform. It's an external API where we basically are trying to connect food delivery, hotel reservations, appointment bookings, things like that into Yelp. And if you're so inclined toward Twitter, you can find me at Scott Triglia. I'll be ignoring it for a little while, but I'll get back to it in good time. All right, today's goal. Hopefully we're going to talk about legacy code. I'm pretty sure that's going to happen. With any luck, you're actually going to come out of it feeling a little more prepared for success. And I'm absolutely going to be targeting this at your first legacy code base. If you've been around the block, done this a few times, hopefully you'll still find some useful anecdotes. But before we get into it, I have to admit to a bit of a theme. So personally, if there's one thing that I associate with dealing and diving into legacy code, it's going to be this goofy guy, Indiana Jones. So you might be thinking to yourself, well, Scott, is that because of your manly physique or obvious roguish charm? I appreciate that, but yeah, that's not quite the reason. We'll get there in good time, but for now, hold that in your mind. All right, what is legacy code? So I was trying to come up with the definition. I was really tempted to say it's old, but I decided to go with instead it being mysterious. Main reason behind this is I know from my own experience, some code that is very much not old, is in fact was worked on maybe a week prior, has felt like legacy code. And the reason for that wasn't that it was ancient, it was that the lead developer left, or the only people that understood it weren't there anymore, or something similar to that. So this is one of the first places that kind of that connection with Indiana Jones comes in my head. I like to think of it in terms of maybe exploring an ancient building of some sort. And one of the big reasons I like to say that is essentially when you're going through this old code base, nothing's going to look familiar. You're not going to know what's going on. But that doesn't necessarily say anything about the design of it or the fact that it didn't have a purpose or the fact that it was actually poorly made. It's more about sort of you being out of context, you not knowing what you're looking at or not knowing how to interpret it. So me not speaking or being able to read hieroglyphics says nothing about whether or not that's a valid language in its own right. But that's not all legacy is, right? It's not just mysterious. A sort of realistic part of it is that it's also really unpleasant. Nobody gets excited about jumping into legacy code. Nobody came here expecting me to talk about how awesome the experience is. It's not something that you enjoy doing, and I think there are a few reasons for that. Really, the fact that it's unfamiliar to you is one of the things that makes everything else more unpleasant about it. You never know when you're kind of walking along and you're going to come across an undocumented bug, right? Some really nasty, sharp corner in the library. Maybe more than anything else, you just don't really know what you're working with, and something that could be quite safe for another person is completely mysterious and dangerous to you. And lastly, legacy code often ends up not being your idea. It's relatively rare, I think, that people opt into dealing with legacy code. They see something that nobody understands and they say, yes, that's the thing I want to spend all of my time on, right? It's much more frequent that someone comes in and says, congratulations, everyone else has gone. This is all yours now, good luck. So that's often the kind of context around getting it. And in a slightly stretched analogy, Indiana Jones also had something similar happen to him. So he got a package in the mail, turned out to be this diary, right? This diary full of arcane drawings and mysterious kind of indications and clues. And he sort of could bumble around and figure it out, but for the most part, he didn't know what he was looking at. And he really needed to dig in and understand it better. And this kind of thing, just arriving out of the blue with no forewarning is kind of how it can often feel. All right. That's the bad news. The good news is, and I think we're kind of in a privileged spot dealing with software here, is that we can make it better, right? We have the privilege of working with code, something that we can manipulate. And when we see things that are confusing or hard to understand or we don't follow, we actually have the ability to fix all of those problems over time. So that's the really good news, and it feels pretty positive and exciting. And it can feel like there's a lot of good things you can do in a legacy code base. Unfortunately, it's pretty easy to rapidly run into problems with this strategy, right? We want to improve the code. but we've kind of already admitted to ourselves that we don't really understand what's happening or how the code works. And we could just go in and start messing with stuff and trying to fix things, but if we do that, we're honestly pretty likely to just break it completely. And in the meantime, something not to be discounted, it's easy to feel like you're doing a bad job while this is all going on. I still remember my first old code base that I took over. Everyone agreed it was kind of terrible. I had a lot of trouble dealing with it, and I just kind of sat on it for about 3 months, felt like I wasn't making forward progress, and it wasn't clear if I was ever going to make forward progress. So it's very easy to get into this situation where you think you know what you want to do, you can even see it right in front of you, but any movement you try and make towards a better world feels like it's just sinking you deeper and deeper into this pit of terrible code. So clearly we're going to need some sort of better approach, something cohesive that addresses these problems. With any luck, we'll come out of this talk with some of those ideas. So our rough game plan is 3 parts. We want to start out by taking this code we don't understand and just feeling like we're starting to comprehend it. We're not going to get there immediately, but this is where we're going to start at. After we feel like we actually understand what the code is theoretically doing, what we believe it's doing, we want to be able to make some claim that the code actually matches up with that reality, right? We'd like to guarantee it, and going forward as we improve it or change it or do different things, we want that guarantee to hold true. And then lastly, but not at all least, we want to kind of have an eye towards how we're communicating with the people we work with, keep an eye on how we're personally feeling about the project and our motivation levels, and make sure that this is all going in the right direction as well. Okay, so let's start out with comprehending the code. And you might have the valid objection that at this point we don't understand it. We've accepted that as the starting point. We say we want to understand it. That's all well and good. That sounds like a nice goal. But there's not at all an obvious way to get from A to B, right? In Indiana Jones's case, with that old diary we talked about, he kind of had this easy. He was able to just go and talk directly to the original author. Turns out if you're Harrison Ford, that's Sean Connery. He lives a pretty sweet life, I'd say. And he just explained everything, right? He said, hey, I don't understand what's going on this page, and Sean Connery basically walks him through it. I'm going to assume we are not in that excellent position, both because we don't have a direct line to Sean Connery and because we can't actually find the original author, right? This is kind of the worst case scenario. It's, at least in the scenarios I've seen, pretty common that you don't have access to whoever wrote the code, and so they can't walk you through it. You might have documentation if you're really easy, but I'm also going to assume it's kind of terrible or you don't trust it at all, either one of which are pretty common. And as we dive into this code, given that we have nobody to show us the way and we have no documentation we trust, it's going to be really tempting for you to just fix things, right? You're going to see stuff close at hand, something, maybe a poorly named variable, maybe a bad call to a function, and you're going to just want to reach out and grab it, right? Fix it right in front of you. Unfortunately, the reality is when you tend to do these kinds of things, they can go not intended, right? Not as intended. And this is the kind of thing where you wanted to make the world better, right? You wanted to improve your position, you wanted to understand the code base and improve it, and instead, what? You get death boulders, right? That's not very good. So we're going to see if we can come up with an approach that doesn't involve just seeing things and going for it and seeing what happens. In my own experience, this little loop has worked pretty well. I'm not going to claim that this is anything revolutionary. Quite honestly, this is pretty standard advice in this kind of area. But what we're going to try and do is basically start small. We're going to start with changes small enough that we can reasonably believe they're not going to break anything. We're going to make sure we're building up certainty, both about what the code is doing in practice with testing and about how it interrelates with itself. And we're going to use this to improve the overall clarity and build ourselves up. So from the foundations, things that we can just stare at and understand, to how functions work together, to how modules work together, and so on. Our example code base for today is going to be an open source project of my own. I do this not because it's a particularly good example of a legacy code base, but because I can show the code to you, and I wrote it, so I'm not going to feel bad if I bad talk any of the code in it. It does HTTP request response validation. You don't need to care a lot about that, but you'll see hints of that in a lot of the examples we see. So let's go ahead and dive in and see what this process of going from sort of no information to understanding a code base looks like. There are a variety of difficulties you're going to come up with in dealing with legacy code. I've done my best to highlight some Python-specific ones, things that Python does a particularly poor job of helping you out with, and give us an idea of what this might look like in practice. So here's a function. It's just a function I picked out of the code base. I would say it's relatively simple in sort of a net complexity perspective. Not too many lines, relatively few function calls, no conditionals. But I don't think it's very easy to understand what's actually happening here. In particular, when I see a parameter like models, Python as a language gives me no information about what that is. The sort of code as written doesn't actually tell me anything either. It just gets passed along to some other function call. Great. And I can't really tell what's happening, right? The return type here, not self-evident. It says validators.extend. Validators sounds like, I don't know, it's plural, right? Maybe it's a list or something. Those have an extend method, so we can assume maybe that that's true. But we don't have a lot of information. So what can we do in this situation? One of the safest things that you can start with, at least, is just documentation, right? Adding comments, adding docstrings to methods like this that are woefully lacking. Now, this isn't quite guaranteed to be safe. You can still break things by adding comments, but it's almost as simple as it gets, and it's a good place to start. So we've gone ahead and done our investigation, maybe dropped some breakpoints in, figured out what these variables actually are in practice. In PEP 257, I think, practice, we've kind of got our top line, single line description of what the function does, and we've stolen this really cool feature of Sphinx, which is describing each of the parameters and the return values in detail. So we now know through this investigation that this actually returns some class, JSON schema validators.validator, and a bunch of extra information, right? And this is a really good place to start. Sphinx has the nice upside of now we can also use those parameter notations we talked about to render really nice documentation. So if this were actually rendered and all the package was successfully built as documentation, this validator link here might link out to documentation on that class. And we have something a little more explorable going forward. OK, that was simple, right? Just adding comments. What do we do when we inevitably hit some code that doesn't do what it's claiming it does? A pretty simple example here. We have a comment that says, please do not validate unsuccessful responses in a particular version of a dependency, right? Version 1.2. We have code that is cheerily going along and completely ignoring whatever that version dependency was, right? There's no check there. It doesn't look like it matches the comment. I was confused when I read this. So this is the kind of thing that you're going to find probably all over. Sometimes it's comments in code. Sometimes it's code disagreeing with names. Many different ways it can happen. So it would be easy for us to say that we just want to update it, right? This is our idea. Let's make the code better than we found it. One relatively safe way of doing this is we can at least adjust the comment, right? Maybe I file an issue. I say, look, this comment seems flat out incorrect. Relate it back to the code it was coming from. This is very low risk, and it at least makes it less confusing for the next person that comes along. But of course, what we'd enjoy doing is actually modifying the code, getting some idea of the version we're currently on, and comparing it to make the comment true, right? In our case, when we said if we're using 1.2, what we actually meant was if we're less than 2.0, because that was a breaking change. But unfortunately, we're going to run into a problem here. We want to change the code. If we're going to do that, we want to also test it just for our own safety. But the code is not always going to play nicely with us, right? Especially in old code. So let's zoom out. Let's see the function that was in. Validate response. Again, not awful. Maybe 20 lines total. Couple if statements. But this is going to be a pain to test, right? What I actually care about testing is the execution of that if statement. Did we return or not, basically? To do that, I have to figure out how in the world do I call this function? How do I construct its arguments? How do I dodge this intermediate return statement? Because I don't want to hit that. How do I make sure I hit the second return statement? And you would be forgiven for feeling like the only way to do this is to refactor the code entirely to make it more testable. Luckily in Python, we have access to the mock library, which is very powerful. It does a lot of different things. But it's also sort of a great cheat in situations like this when you want to modify code as little as possible. So don't get too hung up on the syntax here, but the mock library gives you the ability to build fake objects. You can see on the third line here, I build a fake validator map. And what I'm doing is I'm just saying, trust me, it's going to have an attribute named response, and that attribute's going to have the value fake validator. And doing this, you can see I kind of build up a few objects on top of each other. I'm building up something that I know will execute a very particular path through that code. And this is, maybe you could argue, not the nicest way to test this code, but it is a way to test it without modifying anything in the existing function, or at least minimally modifying the existing function. And lastly, the mock library also has this really cool function down at the bottom where I can assert whether a method on the mock was called or not. So if we take a look back at the code, the very last line here calls validator.validate, and it should not execute if that if statement was run, right, if we returned. And so we can basically just at the end of our test assert that a certain function was not called, and that succeeds with what we're interested in testing. OK. So a lot of details, a lot of examples, but let's try and see if we can kind of summarize the approach. We're starting from no knowledge, so we want to build up knowledge, right? We want to build up understanding of the code, and we're going to do that with a bunch of small changes. We're going to start with the kind of things that we can just stare at, we can see in front of us, and say, yeah, this change is probably safe. And while we're starting that simple, we're going to keep adding more and more tests. We can build this up from very small changes, things like comments, to larger changes, things like modifying function names or function arguments, until we feel like we're actually understanding how the system works together and the tests are guaranteeing that. And our goal here is to build confidence, right? By default, if we touch something, we're likely to break something. These unit tests, as we build them up, maybe they already exist in some partially built form, maybe they're completely gone altogether, but either way, we're going to be giving ourselves more and more confidence that we're doing the right thing. And our overall goal here is we're kind of aiming to start untangling the incidental complexity of this old code base from what actually has to be there. If your code base is sufficiently old, I guarantee it has a ton of incidental complexity, right? These things grow less like gardens and more like weeds. Things entangle everywhere. There's going to be all sorts of accidental and unintended side effects. So one of your principal jobs when you're diving into this code base is to just start pruning away at the edges of those problems. You're not looking to fix it. You can't fix it from the start. That's dangerous. But you can start cleaning up the landscape and moving yourself to a position where you can actually do the big refactorings. OK, let's talk about, after we feel like we understand the code base, how we guarantee that understanding actually matches reality. And it's going to be kind of more of the same. We're looking to take that approach of building up tests that give ourselves confidence, of understanding code, and building up on ourselves to the next level. So this often happens when you get to the point where you say, great, I feel like I know what's happening. I want to make a big change, right? I'm not going to make a comment change or variables or add a method. I want to do something fundamental to how my library or project works. In my case, that was delegating a particular part of validation. I wrote it myself when it first came along. And at some point, partway through the project, I said, hey, this other package will do a much better job. I'd like to rip out my code and replace it with calls to the external package. Not too bad, and it shouldn't affect users, right? From their perspective, things should just carry on the way they've been working. Maybe a couple bugs will get cleaned up. Should be good. So if we hop back to our validate response method, we see all sorts of calls here dealing with validation, right? Validate map, validator, a lot of very confusing naming. And we're looking to basically remove those or change who they call or something similar. So we can start going through and saying, OK, yeah, I need to change this bottom thing to call out to the other package. Well, that's, we're doing some sort of get up there to test if we have an empty body. I'm going to have to do something with that. And we work through our refactor. And we can get to the point where we've actually, we believe we've replaced the functionality and we've done whatever our large-scale goal was. In my case, farming out validation to this other library. So I ran the tests, and this happened. Bummer. 90 tests, and I got about 52 errors and 20 of them failing. It didn't look terribly good, right? But a funny thing happened. I went back and I actually tried out the library. I compared it, ran validation on a couple sample inputs, and it was working just fine. The job that I had done was successful. We had worked out just fine, and all was going according to plan. And unfortunately, what had actually happened here was my tests were lying to me, right? And this is kind of one of those things that doesn't feel fair. Feels like you've kind of been cheated out of it a little bit. And the reasoning here is that we built all those unit tests. I told you that we were going to sort of protect ourselves with unit tests. And all we actually did was freeze the structure of our code. We would love to go in and change them. But unfortunately, if we do that, we've taken away the only safety net we built ourselves. And so we're going to take it from a slightly different tack. We're going to basically write tests that guarantee high-level behavior. Sam, if you were here just previously, talked a little bit about acceptance tests or functional tests. And we're going to employ that idea to basically assert whatever our users are interested in holds true. And that way we're free to change underlying code. And that's really what we're looking to do here, is we want to remove those old tests that are asserting that an old implementation exists. And if all else is equal, at least, we'd like to go forward and prefer implementation agnostic testing. Now, this won't always be realistic or possible. But again, if we're left with two equivalent choices in testing, and we know we're going to be doing a ton of refactoring going forward, it's nice to not have it bound to the implementation. So in Python, this looks really nice. I find this very straightforward and readable. This is using PyTest. It sort of assumes the existence of some sort of test application with a set of schemas. And basically, all my acceptance tests look like is make a request that I know should have a certain answer and assert that the right answer came back. And you can have a whole bunch of these. This library in particular has a tremendous number of them because it's kind of the end user functionality we care about. And if these are passing, we know that the refactor itself was still safe. So there are a couple lessons we can pull from this. The first one, which may be a little controversial, but I think is still true, is that the end users really don't care about your unit tests, right? We talk a lot about unit tests as if it's something that solves everything, but all that unit tests actually do is they help the developer, or at least they should help the developer, right? If you're running through a code base and you reach a bunch of unit tests that constantly get in your way, that don't feel like they're adding value to the project, they're not protecting you, they're not making the code clearer, then you should consider getting rid of them. And likewise, they're probably not going to be the kind of tests that actually guarantee any functionality you care about for your users. And this really good acceptance testing lets you refactor fearlessly. It's going to involve changing a lot of the underlying implementations. Unit tests are probably going to need to be modified or removed in the process. And this is the way you can do that sanely and safely. All right, so that was a lot about the technical aspects. But I don't want to finish up without talking a little bit about the social aspects of this. Our code, hopefully, is improving. We feel like we're in a better spot from where we started, and we can see a path forward to basically improving the state of the world. But there can still be problems with how we're feeling about the project. I think one of the most obvious of these is it's really hard to feel proud of legacy code. The way we talk about it, the fact that we call it legacy code, the fact that we're often negative about it, can really rub off. I know with my sort of first big project, I often heard other people talking negatively about it. It was a project, internal to the company, consumed by other developers, and it was bad, like objectively bad. And so I would hear people being negative about it. I would have to be honest to myself and say, yeah, they're not wrong. That is a problem. That is impacting people who are trying to use the library successfully. But this is the kind of thing that can be really difficult to work through. And if your code base is large enough or complicated enough, forward progress can also feel tough to measure, right? It can feel like to fix this properly, I'm going to have to spend 6 months working on it. I won't know if I'm succeeding or not. It's tough to see those intermediate goals along the way. So what can we do about this? No silver bullets, I'll say that up front, but some things that have worked well for me. I think measurement is a huge part of it. Being able to say, I know my goal is to make everything better, to make this library really good by the time I walk away from it, but I'm going to set goals that are significantly more conservative than that, right? Maybe your goal is code test coverage, going from wherever you're at to 80% or 90% or maybe even 100%. Maybe your goal is accomplishing specific features or knocking out specific bugs. I think the details matter less than the fact that you have goals, that you've said them out loud, that you've agreed upon them, and that you can measure getting partway to them. And after you achieve them, hopefully you're going to be able to celebrate them, right? And this is not just celebrating to yourself or to your manager maybe, but making sure that you're explaining what's improving and how to the other people that are involved with your project. So I say brag about improvements. I don't like to brag. This is not like terminology I enjoy. Sometimes it helps me to think about it like this. So it's less about saying, look how awesome I am, and maybe more about saying, look, I know there's a lot of bad information out there. I know that what you think is not accurate anymore. That bug doesn't exist. I solved it. And you're running around basically updating people's mental caches. But the common theme for me, and what I think the takeaway is on this whole social side of things, is that you really have to be understanding. Working on legacy code, owning a legacy code base is not an easy or enjoyable task always. You should be aware of that and not expect it to be, right? Don't be alarmed when that happens, and keep an eye on your motivation going forward. In addition, bad code affects people, right? It affects the people that use it and the people that interact with it, and that's kind of tough. All right, so how can we wrap up? These are a lot of different tools for success. There are many more. Don't feel like this is an exhaustive list. But I hope that it's given you a good place to start, and I would say the most valuable thing for me has been mentorship as I was working through code bases like this. We started out by working from no understanding and getting to a point where we believed we understood what the system was doing. We went from there and basically tried to take that understanding that we believed was true and actually prove or disprove that it was accurate. And this gives us a solid foundation to make further changes to the library and feel like we're always moving it forward while still not breaking things for the people that care. And lastly, we said that we need to really make sure we're communicating effectively outward to the people that care about the library, and that we're making sure we keep an eye on our own interior motivation and make sure that we can see the process improving and see the light at the end of the tunnel. And I hopefully overall, if you work through this advice and find it useful, you'll basically see a lot fewer of the death boulders and experience a lot more success. So with that, happy to take any questions or catch up with me after.
Put your hand up if you have a question for Scott, so I can run the mic up to you. It's got to be the person in the middle, doesn't it?
Always in the middle.
Yeah, you talked about mentorship, but what happens if you're the Sean Connery and you just hired a couple of Harrison Fords? Yeah, and you acknowledge it's bad code and whatnot, but what do you recommend on the other side of things?
Sure. So basically, how do you be a good mentor to somebody who's doing this kind of process for the first time? It's a great question. I think I can say personally, I've been in that position relatively recently on a project, kind of the one I was referring to where it became legacy code out of nowhere very quickly. I think, speaking from when I was on the flip side of that, when I was the person encountering it for the first time, the biggest problem I had wasn't making the code better, because I felt like I could do that. And I think there are a lot of resources around for making code better and knowing how to make those forward steps. I think the biggest thing you can do as a mentor is sort of guide the process and make it clear what to expect, what not to be surprised by. Don't be surprised when you feel like you're not making forward progress. I think all of that motivation side of things is very important for mentors. And as much as possible, of course, if you see someone walking towards a particularly sharp corner, or they're likely to hit a bug that you can see in advance, of course, let them know that.
Any other questions?
Yeah, you're going to get the exercise.
For every code base we get, we assume that the features are used, right? Mm-hmm. But sometimes it's like you can simply remove it. You can simply clean the code. It's like you're comparing version 1.2 and it's version 4.0 now. No one is using it. So how do you do that? How do you clean up unused code that has tests that, yeah.
Yeah, well, Python doesn't exactly have our back on that one, does it? It doesn't make it easy on us anyway. I mostly work in variations on web development. So for me, a lot of the answer to that kind of question is you have really good logs, right? So I'm writing a service, other people are calling it, and hopefully, if I'm doing my job and I'm paying attention, I know how many incoming requests are coming to every part of my code, at least on the service boundary. So I think a lot of logging is always helpful. There are tools out there. I think there are dead code tools for Python in particular that are available, if that's possible with your specific application. Yeah.
Any more questions? Well, it doesn't look like it. So everybody please give Scott a big round of applause.